Hello, welcome everyone. Welcome to the class once again. Today, in continuation of our topic on cubes, we will be discussing about expressing cube into prime factors. So by the word prime factors, we come to
Hello
mind,
again.
comes in our mind two words, prime and factors. So last time when we were discussing about squares also, we try to factorize the number into its prime factors, and then we try to form pairs. If pairs can be formed, prime factors with prime factors, then we can say that that number is a perfect square. Is it? Do you remember?
Yes.
Yeah. So similarly, regarding cubes, we will be expressing the number into its prime factors, product, and by expressing the number as a product of its prime factors, and we will try to make triplet rather than pairs. Okay, in cubes, when we try to find perfect cubes, we will try to make triplet, not only pair. We will try to make triplet. Triplet means grouping of three. So prime factors, why is it so important? Why is it so important? Prime factors. Now, two words are there. One is prime, and the other is factors. Now, what is prime number? Can anybody define? Please define prime number. Anybody? Voluntarily, please explain to me what is prime number?
Sir, a
Yes.
number which is only divisible by itself and 1.
Yes. Can you repeat it once again?
A number which is divisible by itself and 1.
Divisible by one and itself. Only by one only. The word only should come, because if you say without mentioning the word only, if you say if a number is divisible by one and itself, then you have left room for other to check for other numbers, to check that if other numbers can also divide the number. So you should use only one in the number itself, so that other numbers are 100% left out. Are you clear? Clear.
Yes.
Yes.
Prime numbers are numbers
Yes.
that are divisible by one and the number itself. Okay, so prime numbers. Or in other words, we can say that prime numbers are numbers which has factors as one and the number itself only. Factor. Okay, factor. What is factor of a number? What is factor of a number? Can anybody tell me what is a factor of a given number? Anybody? Yes, anybody, please. Yes, what is a factor of a given number? Yes, anybody? So I have used the word factor. What is a factor? Yes, please tell me. What is a factor of a given number? Hello. Am I audible to you? Hello.
Yes.
So what is a factor of a given number? So factors, I am telling you, factors are numbers which can divide the given number exactly. Okay. Factors, if we say factors of a given number, that means those numbers, there may be many numbers or there may be only two numbers. In the case of prime number, there will be only two numbers, one in the number itself. So factors are those numbers which can divide the given number exactly. All right? All right.
Yes.
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 Factors are numbers. Factors of a given number are those numbers which can divide the number, the given number exactly. Which can divide the number, given number exactly. Which can divide the given number exactly without any remainder. Okay. So tell me, what are the factors of 36? Yes, tell me, what are the factors of 36?
2. 1, 2.
You start from the smallest one.
1, 2, 6.
1, comma, 2, comma. How about 3?
3. 3.
Yeah. So 3. Yes. Others?
6. 6.
6. Oh, 4. 4, 9, 36. Okay.
6.
So 6. 6, 6, 36.
36.
Correct?
Yes. Yes.
So when I say 1, when I say 1, 136 or 36, you write it down. Okay? Comma. When I said 2, it is 2, 18 to 36. Okay? When I say 3, it is 3,
12.
12 or 36. When I say 4, it's 4,
9.
9 or 36. When I say 6, it is 6, 6 or 36. Okay?
Yes.
Yes.
So I'm not writing the 6 again. So these are the factors of 36. These numbers 1, 2, 3, 4, 6, 9, 12, 18, and 36 can divide 36 exactly without giving any remainder. So these are the factors of 36. Okay. Okay. Yeah, 36 is a
Yes.
composite number because it has other factors other than 1 itself. 1 is here and itself means 36 is here, but there are also other numbers which can divide 36 exactly. So it is a composite number. So this is a composite number. And you know what is the composite number? Composite numbers are numbers. Yes, define. Anybody? What are composite numbers? Yes. What are composite numbers?
Hello.
What are composite numbers? Yes, anybody? Hello, am I audible to you? Hello?
Yes.
Hello? Am I audible?
Yes.
So tell me, what are composite numbers? Define composite numbers. Numbers having other factors other than
One and itself.
one and itself. These are composite numbers. Composite numbers are numbers having other factors other than one in itself. Okay. So what are the
This
factors of yes, tell me factors of 5? What are the factors of 5?
One and
one
five.
5
1 and 5. So 5 is a prime number. Am I right?
and number.
Yes.
Prime number. Now, uh, let's do the prime factorization of 36. Okay, let's do the prime factorization of 36. Okay, let's do the prime factorization. I don't know if that symbol is available or not for prime factorization. Is it available? Let me do this. So what is the smallest prime number? What is the smallest prime number?
Two. Two.
Yeah, 2 is the smallest prime number. So we will start from 2. Okay. So 236, what is the
18.
18
yeah. So we get 18. Okay. So we get here 18. Now can 18 is 18 still divisible by the smallest prime number 2? This is the step by step.
Yes.
So we will still continue with 2. That is what the question you should ask. It's like an algorithm. You can write a computer program to find this step by step procedure to find the factors of a number. So since 18 is still divisible, exactly divisible by the smallest prime number, we will continue with the smallest prime number, that is 2. Now what is the number will come here? What is the quotient? We are looking for prime numbers which can exactly divisible. So what is the quotient? It is 9. Am I right? Without any remainder. Now the new number 9 will become the quotient 9 will become the new dividend. That is how computer program are written. The quotient 9 will become the new dividend. And what will be the new divisor? Can 2 still be the new divisor? Can 2 still be the new divisor? Can 2 still divide the 9 exactly?
No.
So
no
then we
No.
have to move to the new prime number, next prime number. We have to move to the next prime number.
3
Since the smallest prime number 2 cannot exactly divide the new dividend, that is 9, the new dividend. The earlier quotient became the new dividend, and the new divisor will be 3, the next prime number after 2. So So what will be the number here? It will be 3 3
3.
is 9. Am I right? 3 3 is 9. Now
Yes.
you have to check also if the quotient became a prime number. If the quotient becomes a prime number, then the step is stop. It ends here. Okay. If the quotient becomes a prime number, then the step is finished. Okay. This was not a prime number,
Yes.
so we still continue. This was still not a prime number, so we still continue. But here it is a prime number. So the if you are to write a computer program to determine this step-by-step procedure and to find out the factors, you have to do like 36 is the dividend, then start with the smallest prime number to determine check whether if it can exactly divide, yes, then continue with it, then give the quotient 18 and it will become the new dividend. Same step will same logic will follow, like say the new dividend is the earlier quotient and the new divisor we have to determine whether the smallest prime number can still divide, yes, then it will continue with 2, but if no, suppose here it becomes 9, the quotient you have to check in every step the quotient whether it is a prime number. If it is a prime number, if the quotient is a prime number, that step is finished. Now check number 9. Is 9 a prime number? No. Then you check what prime number can divide the new dividend, that is 9. So can it be divisible by the smallest prime number? No. Then go to the next prime number. It will be 3. Then you divide the new dividend, that is 9. That was the earlier quotient. And then in the next step, this quotient, new quotient, check the new quotient whether it is a prime number. Yes, then finish. This is how computer program, this algorithm. Do you follow what I'm saying?
Yes.
So now if I have to write 36, because this is 36, I will write like 2 into 2 into 2 into 3 into 3. This is 36 because 2 2 is a 4, 4 3 is a 12, 12 3 is a 36. Okay. Again, if we were to talk about square, when we did have discussed about this, so we have to make pairs, like it is making a pair, 2 is making a pair because there are two twos here and there are two threes here, so it will be 3 square. So actually we know that a into a to the power n into b to the power n is ab to the power n whole. Okay, like this you can say. Is it okay?
Yes.
So this is 6 square, and this step is why I have just said for this step I am writing in third bracket. Why? Because a to the power n into b to the power n is nothing but is equal to, within the bracket, a into b whole power raised to the power n. Is it okay? Is it okay?
Yes.
Yes.
This is this two step, how it come. Okay, how the 2 into 3 whole square come. So it is 6 square, and yes, 6 square is 36. That means 36 is a perfect square number, and root over 36, square root over 36 will also be 6. Now to determine what are the factors of 36, like say I just want to aid something for your higher knowledge, how to determine the factors. Okay, we know that we have just checked that the factors of 36 were 1 2 3 4 6 9 12 18 and 36 were the factors of 36. Now by the method of prime factorization, this is what we are expressing. Okay, a given number. Here we are expressing a given number as the product of its prime factors. As the product of its prime factors, we are expressing a given number as a product of its prime factors. Okay, any any number can be expressed as a product of its prime factors. Any number. Okay, any number can be expressed as a product of its prime factors. If it is not a perfect square, we will not be able to make pairs in some prime factors. If it is a perfect square, we will be able to make pairs for every prime factors. But if it is not a perfect square, we will not be able to make pairs for every prime factors. Yeah, it may be able to make pairs for some prime factors, but it may not be able to make prime factors for other prime factors if it is not a perfect square number. Is it clear? Is it clear?
Yes.
Yeah. In class 10, I think, so in class 10, you will be learning about that property that we can express any number as a product of its prime factors. Okay? Every number can be expressed as a product of its prime factors. So now 36, how you determine the factors of 36, like 1, 2, 3, 4, 6, 9, 18, 12, 36, all those things. You can also find out with the help of this expression of a given number as a product of its prime factors. That means from here, you can know all the factors of the given number. So in the beginning, you just write 1 because 1 will exactly divide every number. And you write 36 because the number itself will also exactly divide itself with the quotient 1 and remainder 0. So now next is you take one prime factor, whatever is there, 2, 2, 2 occurs here. So just write a single 2. Then check for other prime factor other than 2. Yes, it is 3 here. So 3 you write. Is there 5 here? No, you will not write. Is there 7 here? You will not write. So they are prime factors. 5, 7 are also prime factors, prime numbers. But since it is not occurring here, you will not write here. Now, again, then you go for combination and permutation, like 2 twos. Yeah, 2 twos are 4, you write. Now, you write also 2 twos are 4 have, yeah, 2 and 2 have been played a match. They have played the match. And then this 2 and this 3 can also play a match. Then 2 3 is 6. This 2 and this 3 will also make 6. It is the same number, so we just ignore it. This 2 can also make 6 with the 3 here, so we ignore it because it is the same number. Now go for this 3 into 3. Yes, and so 3 into 3 is 9, so it is a factor. Now you go for 3 to the 6. It is the same number, so ignore it. This same number 3 also 2. So we have done 2 2 pairing, like say 2 3 is 6, 2 2 is 4, 3 3 is 9. So match between one player and other player already khatam. Then go for 3 3 numbers. Okay, now 2 2 is 4, 4 3 is 12. So this is 12. Now 2 2 is 4, and with this 3 also, with this 3 they have played. With this 3 it is the same. 2 2 is 4, again with this 3 also 12, so we ignore. Now go for this 2 3, and uh, combination with two threes and one two. Yeah, it will give 18. Similarly, with this two also, with with these two threes, it will still give you 18. So we ignore it. So these are the factors of 36. And if you multiply all the four numbers, if since I have done with two numbers is and I have done with three numbers, if you combine all the four numbers, it is still 36. So 36 still there. So these are the factors of 36. So are you clear how I get all the factors of this number with the help of the expression of the given number as the product of the prime factors? That means how I
Yes.
determine the all the factors from the product of its prime factor. Everybody got it?
Yes.
So uh, similarly for cubes also, and this is an addition of your knowledge so that you know what is prime factors, why you express a number as a product of its prime factors. Yeah, every number can be expressed, any given number can be expressed as a number of is a product of its prime factors. Okay, every number will be prime number here. This product, every number, there will be not like say 16, 19. We will be expressing every factor, single factor as a prime factor. And then ultimately you can determine all the factors of that number also. So actually, these are the original factors of the given number. This is factorization. Yes, this is factorization, but expressing it as a product of prime numbers. Okay, every number can be expressed this like this. Every number. Okay, these two, these three are prime number. It can happen with five also. So every number can be expressed as a product of the prime factors. Now, uh, then with the help of prime factors, you can find square also, whether it is a perfect square number. And if it is a perfect square, you can find out the square root of the number. I mean, square root of a given number with the help of this expression of factorizing the given number into the product of its prime numbers, prime factors. Now, let's talk about cubes. Um, let's say a cube number, small cube number, say um, uh, 216. I will be uh, 216. Okay, 216. Now look how I do. Okay, without even using the this symbol step by step. Okay, without using this division symbol, how I do just follow. Okay, 216. 216 is start with the smallest prime number. It will be 2 into 108. Okay, am I right? Am I right?
Yes.
But just keep in mind that is 108. Okay, just keep in mind. Now I will not write 108. Now 108 can be expressed as a product of 2 into 54. Am I right? 108 can be expressed as a product of 2 into 54. Am I right? With the prime number 2. Okay? Okay.
Yes.
But I will not write the 54 here. I will keep it in my brain. 54. Now 54 is still divisible by 2. So I go again with 2. And I will multiply with 2 to get 54. I will multiply with 27. This 27. But I will not write the 27. I will keep it in my brain. 27. Now 27 cannot be divided by 2. So I will use the next prime number, that is 3. So 3 9 is 27. But I will not write the 9 here. I will keep it in my brain. Then 9 is not divisible by 3. Yes, it is divisible by 3. So I will write 3 into 3 because the last 3 is a prime number. So this is how you can do also by keeping it in your brain, the next device, the next dividend, the next quotient. Okay. So it is nothing but 216 is nothing but it is you have to make triplet rather than pairs. In perfect square, you try to make pairs, but in perfect cube you will try to make triplets of prime numbers. So it is, there are three twos, and yes, there are three threes. So this is how you can find whether a number is a, if it can make triplet, yes, it is a perfect cube. But if it cannot make triplet, it will not be this one, uh, perfect cube. And then question will be like, what number should be multiplied, like the earlier we have done for square also, what number should multiply to get the next perfect cube number. Do you clear, are you clear what I'm saying? Are you clear? This will be 3. Are you clear what I'm saying?
Yes. Yes.
So this way, this step is the same thing here. A n into b n equal to a into b whole n. So this is how you can get the cube root of a number. Like 216 is 6 cube. So 6 will be the cube root of 216. 6 into 6 into 6 will be 216. So thank you for watching. Please subscribe the channel and press the like button. We will continue the class further. Thank you for watching again.